I think up to 21 has been given, sir, that day, sir. So
That
from today,
22,
sir,
sir.
22,
Yeah,
sir.
22, sir.
Yes, sir. After 22 last class, they have present their topics.
okay. The rest are prepared with their.
Sir, after 22, anyone can present. Hello.
So please start the discussion. Hello, I'm audible now.
Yes, sir.
Yes,
So
sir.
without wasting the time, we should start it. So roll number wise, who are left, they may start. Rajesh,
Yes, sir. So, but so sometimes some students are not in the meeting, sir.
okay.
So number 22, 20 after 22, roll number 23. So I think roll number 23, not roll number 24. Roll number 24 left the class. Roll number 25, Robert, can you present? Hello. Roll number 30, Kritika.
Okay, I'm going to present then. Is my screen visible? Hello?
Visible, but our just the topic blind search and break search techniques.
Oh, wait.
Uh,
Okay, let me search. Wait for some time.
Okay, then roll number 32. Roll number 39. 40. Roll number.
Yes, 39 is here.
Devasis, can you present?
Yes, I can present.
Okay.
Wait.
Present. Present.
Rajesh, is my screen visible?
Yes, your screen visible. Start your presentation.
So, good afternoon, everyone. My presentation is on blind search techniques. Uh, a blind search, also called an ununiform search, is a search that has no information about its domain. The only thing that a blind search can do is distinguishing a non-goal state from a goal state. The uniform search or blind search techniques does not contain any domain knowledge such as closeness, the location of the goal. It operates brute force way as it only includes information about how to traverse the tree and how to identify leaf and goal nodes. Uniform, uh, uninformed searches applies a way in which search tree is searched without any information about the search space like initial state, operators, and test for goal. So it is called blind search. It examines each node of the tree until it achieves the goals node. Then BFS, breadth first search. Breadth first search goes through the tree level by level, visiting all the nodes on the top level first, then all the nodes on the second level, and so on. This strategy has the benefit of being complete. If there's a solution, it will be found, and optimal as long as the shallowest solution is the best solution. However, the way breadth first searches achieves this by keeping all the leaves nodes in the memory, which requires a prohibitive amount of memory when searching anything more than a very small tree. Depth first search. Depth first search goes through the tree branch by branch, going all the way down to the leaf nodes at the bottom of the tree before trying to next branch over. The strategy requires much less memory than breadth first search since it only needs to store a single path from the root of the tree down to the leaf node. However, it is potentially incomplete since it will keep going on down and one branch until it finds a dead end, and it's non-optimal. If there is a solution at the fourth level of the first branch tried and the solution at the second level, then and the one next one over, the solution at the fourth level will be turned. Thank you. That's my presentation.
Okay, thank you, Devasis. After Devasis, can anyone start? Victor, are you there?
Yes, yes,
Can you start your presentation?
yes. Just a minute.
Okay, start then.
Is my screen visible?
Yes, Victor, start your presentation.
Okay. Good afternoon, everyone. My name is Victor, and today's topic is blind search technique in artificial intelligence. And uniform search is a group of wide range usage algorithms of the era. These algorithms are brute force operations and they don't have extra information about the search space. The only information they have is on how to traverse or visit the nodes in the tree. Thus, uniform search algorithms, huh?
Victor, please do the slideshow so we can see the large slide.
Last slide.
Last slide नहीं slide show कर.
स्लाइड शो नहीं हो रहा है क्या?
स्लाइड शो हो रहा है लेकिन स्लाइड शो का जो फुल स्क्रीन कर मतलब.
अच्छा अच्छा अच्छा, जस्ट अ मिनट.
हाँ देख नीचे में है.
अरे स्लाइड
अरे
शो
नीचे में है देख ना जो जूम आउट करने के
अरे
बाद परसेंटेज में लिखा हुआ है.
अरे F5
प्ले
बटन दबा
बटन
दो
का
ना.
कैसा
These algorithms are brute force
अरे
operation and they don't.
विक्टर
हाँ
अरे स्लाइड में देखो, इधर लिखा हुआ है, इधर ऑप्शन है तो जो स्क्रीन को बड़ा कर दो, नहीं तो पूरा स्लाइड शो कर दो. ये एक डेस्कटॉप का मतलब डेस्कटॉप का जैसे एक सिंबल है इधर नीचे में तुम्हारा
है ना
ऑप्शन.
देख
हाँ
इसके
हाँ
पास जूम आउट है उसको दबाना.
रुको रुको रुको.
ভিক্টৰ F5 টো ক্লিক কৰা নহলে.
हाँ वही.
कहाँ पर है रे?
अरे नहीं तो ऊपर में देख लेफ्ट में फ्रॉम बिगिनिंग लिखा हुआ है ना प्रेजेंटेशन.
हाँ फ्रॉम बिगिनिंग.
में क्लिक कर.
अब ठीक है.
नहीं अभी तक नहीं आया देख. नहीं फ्रॉम बिगिनिंग में क्लिक किया.
हाँ फ्रॉम बिगिनिंग में तो क्लिक किया.
प्रेजेंटेशन मोड हो गया.
हाँ
नहीं हुआ. अरे इधर पे है देख परसेंटेज लिखा हुआ है ना. 83% नहीं लिखा हुआ है नीचे में.
अरे
जो
रुक
zoom
रुक 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 रुक.
टाइम जा रहा है.
अरे यार तू जैसे प्रेजेंट कर रहा था वैसे ही करते हैं ना.
नहीं दिखेगा नहीं ना. तू जो लिखा है सबको नहीं दिखेगा क्योंकि छोटा स्क्रीन है ना.
अरे यार तो देख फ्रॉम बिगिनिंग पे क्लिक किया उसके बाद क्या करना पड़ेगा? राजेश
स्लाइड शो लिखा हुआ है देखो ऊपर, स्लाइड शो.
वो तो कस्टम स्लाइड शो है ना.
नहीं, और राइट जाओ, उधर देखो.
हाँ फिर
मैंने एक फोटो भेजा है देख कहाँ पर क्लिक करने के लिए बोला है मैंने.
अच्छा रुक 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 एक सेकंड.
जल्दी. देखा.
अच्छा 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 अच्छा. वो स्लाइड कॉर्नर जो है ना.
उसके पास वाला 4th नंबर में जा. अभी तो सेकंड में है ना. उसके पास. हाँ उसके पास. हाँ अरे नहीं परसेंटेज के
ये
पास वाला. हाँ कर.
मैंने तो सेकंड किया.
ठीक है. यहाँ पे क्लिक करो क्या?
हाँ क्लिक करना.
हाँ An uniform search is a group of wide range usage algorithm of the era. These algorithms are brute force operation and they don't have extra information about the search space. The only information they have is on how to traverse or visit the node in the tree. Thus, uniform search algorithms are also called as blind search algorithm. The search algorithm produces the search tree without using any domain knowledge, which is the brute force in nature. They are different from informed search algorithms in a way that you check for a goal when a node is generated or expanded, and they don't have any background information on how to approach the goal. Types of blind search algorithm. The various types of blind search algorithm are as follows. Breadth first search algorithm. Breadth first search algorithm is the most common search strategy for traversing a tree or a graph. This algorithm searches breadthwise in a tree or graph, so it is called breadth first search. BFS algorithm starts searching from the root node of the tree and expands all successor nodes at the current level before moving to nodes of next level. The breadth first search algorithm is an example of a general graph search algorithm. Example: in the below tree structure, we have shown the traversing of the tree using BFS algorithm from the root node S to goal node K. BFS search algorithm traverses in layers, so it will follow the path which is shown by the dotted arrow, and the transverse path will be time complexity. Time complexity of BFS algorithm can be obtained by the number of nodes traversed in BFS until the shallowest node, where the D depth of shallowest solution and B is a node at every state. TP equals to 1 plus B square plus B to the power 3 plus B to the power D equals to O BD. Space complexity. Space complexity of BFS algorithm is given by the memory size of the frontier, which is O B to the power D. Completeness. BFS is complete, which means if the shallowest goal node is at some finite depth, then the BFS will find a solution. Optimality. BFS is optimal if path cost is a non-decreasing function of the depth of the node. The next algorithm is depth first search algorithm. Depth first search is a recursive algorithm for traversing a tree or graph data structure. It is called the depth first search because it starts from the root node and follows each path to its greatest depth node before moving to the next path. DFS uses a state data structure for its implementation. The process of the DFS algorithm is similar to the BFS algorithm. Example: in the below search tree, we have shown the flow of depth first search, and it will follow the order as root node, left node, right node. It will start searching from the root node S and transverse A, then B, then D and E. After transversing E, it will backtrack the tree as E has no other successor and still goal node is not found. After backtracking, it will traverse node C and then G, and here it will terminate as it found goal node. Completeness. DFS search algorithm is complete within finite state space, as it will expand every node within a limited search tree. Time complexity. The time complexity of DFS will be equivalent to the node traversed by the algorithm, as it is given by Tn equals to 1 plus n square plus n to the power 3 plus n to the power m equals to O n to the power m, where m is maximum depth of any node, and this can be much larger than the shallowest solution path. Space complexity. DFS algorithm needs to store only single path from the root node. Hence, space complexity of DFS is equivalent to the size of the fringe set, which is OBM. Optimal. DFS search algorithm is non-optimal, as it may generate a large number of steps or high cost to reach to the goal node. Thank you.
Okay, thank you, Victor. After Victor, can anyone, Monji, or anyone between 22 to 44 roll number?
Can I start my presentation?
Yes, yes. Start your presentation, Sanchari.
My screen is visible. Screen is visible or
Yes,
not?
Sanchari. Presentation.
Good afternoon, sir. Good afternoon, everyone. Today's topic is blind search technique in artificial intelligence. So, what is blind search technique? An uninformed search is group of wide range uses algorithm of the era. These algorithms are brute force operation and they don't have extra information about the search page. Page the My voice is audible. You are not. Okay. Hello. Hello.
Yes, it's audible.
Only information.
Continue. Sanchari,
Yes.
continue your presentation. You are audible.
Okay. Okay. So only information they have is on how to traverse or visit the nodes in the tree. Thus, in uninformed search algorithm are also called blind search algorithm. The search algorithm produce the search tree without using any domain knowledge, which is the brute force in nature. They are different from an informed search algorithm in a way that you check for a goal when node is generated or expanded, and they don't have any background information on how to approach the goal. Types of blind search algorithm. There are various blind search algorithm are as follows. Breadth first search algorithm. BFS is a search operation for finding the nodes in tree. The algorithm works bandwidth and transverse to find the desired node in tree. The start searching operation from the root node and expand the successor node at the level before moving ahead, and then moves along breadth wishes for further expansion. The breadth first search algorithm is an example of the general graph search algorithm. Example, in the below structure, we have shown the traversing of tree using BFS algorithm from the root node, so root node S to goal node K. BFS search algorithm traverse is layer, so it will follow the path which which is shown by the dotted arrow, and the transverse path will be, this is initial state. And breadth first starts at 4 level. There are time complexity, space complexity, completeness, and optimality. Time complexity. Transverse BSF until the shallowest nodes where the d equal to depth of the shallowest solution and d is the node at every state, where t equal to 1 plus b equal to o. A space complexity. Space complexity of BSF algorithm is given by the memory size of the container, which is b bracket 0 with bracket b. Completeness. BSF is a complete, which is means if the shallowest goal node is some finite depth, then BSF will find a solution. Optimality. BFS is a optimal if path cost is non-decreasing function of the depth of the node. DFS. DFS one of the recursive algorithm we know. It transverses the graph of the tree depth-wise. Thus, it is known as a depth-first search algorithm, as it derives its name from the way of its function. The DFS uses the stack to implementation. The process of the search is similar to the BFS. The only difference line in the expansion of the node, which is depth-wise in this case. Example, in below search tree, we have to show the follow of depth for first search, and it will follow the order. Root node equal to left node equal to right node. It will start the searching from the node node S and transverse A, then B, then D, and E. After transversing, it will be break track the tree as E has no other successor and still goal node is not found. And it also have four level: completeness, time complexity, space complexity, and optimal. Completeness. DFS search algorithm is a complete with finite space as it is expand very node within a limited search tree. Time complexity. Time complexity of the DFS will equivalent to the node traversed by the algorithm. It is given by the t equal to 1 plus 2 to the power n to the power 2 plus n to the power 3 plus n to the power m equal to O bracket n to the power mn, where m is the maximum depth of any node. In this case, the merge branch larger than d, which is shallowest solution depth. Space complexity. DSF algorithm needs to store only single path from the root node. Hence, space complexity of DSF is equivalent to the size of the rings, ring set, which is O, optimal. DFS search algorithm is non-optimal. It is may generate a large number of the steps or high cost to reach the goal node. Thank you. Rajesh, my presentation is over.
Okay, Sanchali, it's a very good presentation, and I like to ask Gautam to carry on the session.
Okay. Thank you, Sanjali.
Gautam,
Okay, after yes.
মই লাষ্ট টাইম মোৰ শ্বেয়াৰ হোৱা নাছিলে, দিব নোৱাৰিছিলোঁ, এতিয়া দিওঁ নে?
দি দিয়া দি দিয়া।
অঁ অঁ। Good afternoon, everyone. My name is Nandana, and today's topic is blind search technique. So what is blind search technique? A blind search, also called as uninformed search, is a search that has no information about its domain. The only thing that a blind search can do is distinguish a non-goal state from a goal state. Depth first search, which is DFS, is an algorithm for traversing or searching tree or graph data structures. The algorithm starts at the root node, selecting some attribute node as the root node in the case of a graph, and explore as far as possible along each branch before backtracking. The time and space analysis of DFS differ according to its application area. In theoretical computer science, DFS is typically used to traverse an entire graph. For application of DFS is a relation to specific domains such as searching for solution in artificial intelligence or web crawling. The graph to be traversed is often either too large to visit in its entirely or infinite. In such cases, search is only performed to a limited depth due to limited resources such as memory or disk space. One typically does not use data structure to keep track of the set of all previously visited vertices. The next is breadth first search, which is BFS, is an algorithm for traversing or searching tree or graph data structures. It starts at the tree root or some attributary node of a graph, sometimes referred as a search key, and explore all of its neighbor nodes at the present depth prior to the moving on the node at the next depth level. It uses the opposite strategy of DFS, which instead explore the node branches as far as possible before being forced to backtrack and expand other nodes. BFS and its application is finding connected components of graph were invented in 1945. Thank you.
Hello, Gautam. Hello,
Yes,
Gautam.
Kritika. Hi, Kritika.
Okay, next I'm going to present.
Okay. Present.
Good afternoon, everyone. My name is Kritika Bhattacharjee, and my topic is on blind search techniques. In artificial intelligence, search techniques are universal problem-solving methods. Rational agent or problem-solving agent is AI. In AI, mostly use these search strategies or algorithms to solve a specific problem and provide the best result. Problem-solving agents are the goal-based agents and use atomic representation. Types of search algorithms: ununiformed or blind search. The ununiform search does not contain any domain knowledge such as closeness, the location of the goal, its operation in a brute force way, as it only includes information about how to traverse a tree and how to identify leaf and goal nodes. Ununiform search applies a way in which search tree is searched without any information about the search space, like initial state operators and test for the goal. So it is also called blind search. It examines each node of the tree until it achieves the goal node. It can be divided into five main types: breadth first search, uniform cost search, depth first search, iter- iter- depending depth first search, bidirectional search, uni, uni, informed search. Informed search algorithms uses domain knowledge. In an informed search, problem informed is available which can guide the search. Informed search strategies can find a solution more specifically than an ununiform search strategy. It is a way which might not always be granted for best solutions or granted to find a good solution is in reasonable time. In uniform in uni, Informed search can solve much complex problems which could be solved in another way. An example: greedy search, A star search. Properties: completeness. A search algorithm is said to be complete if it guarantees to return a solution if at least any solution exists or for any random input. Optimality: if a solution found for an algorithm is guaranteed to be the best solution among all other solutions, then such a solution for is said to be an optimal solution. Time complexity: is a measure of time for an algorithm to complete its task. Space complexity. It is the maximum storage space required at any point during the search as the complexity of the problem. Thank you.
Thank you, Kritika. Okay, after Kritika, anyone want to present?
Hello.
After
মই
Kritika?
প্ৰেজেন্ট কৰিছো ৰখা
Hello.
Okay, Dipansh.
স্ক্ৰীন ভিজিবল হৈছে
Yeah, visible.
ওকে মাই নেম ইজ
Divyansh. Hello, Divyansh.
Divyansh Bora sir. I am from Integrated MSc 5th sem and planning other than hello
শুনিছো তুমি
Hello.
স্ক্ৰীনখন হেৰি কৰা তোমাৰ লেটাৰ বিলাক ভিজিবল হোৱা নাই গম পাইছা ভালকে ভিজিবল নহয় স্ক্ৰীনখন ভিজিবল আছে অলপ ডাঙৰ
ৰখা
মোবাইল ভিউ কৰি দিয়া নহলে
এতিয়া 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 ঠিক আছে হেল্ল'
ঠিক আছে কিন্তু লেটাৰবোৰ ভালকে হেৰি হোৱা নাই অলপ জুম কৰি দিয়া নহলে
জুম কৰিলে মই ক'ব নোৱাৰিম ৰখা কৈছো ৰখা to discuss about the topic blind search technique. Blind search, also called uninformed search, works with no information about the search space other than to distinguish the goal state from all the others. The following applets demonstrate 4 different blind search strategies using a small binary tree whose nodes contain words. Just enter a word in the text input field. Your word doesn't have to be in the tree and click on the start search button in order to begin the search. The nodes will change color to red as they are visited by the search. Blind search techniques can be distinguished in many mainly it can be characterized into 4 different types. First one is breadth first search, second one is depth first search, fourth one is depth limited search, and the fourth one is interactive deepening. First one is breadth first search. Breadth first search goes through the tree level by level, visiting all of the nodes on the top level first, then all the nodes on the second level, and so on. This strategy has to benefit of being complete and optimal as long as the syllabus solution is the best solution. However, the way breadth first search achieves this is by keeping all of the leaf nodes in memory, which requires a prohibitive amount of memory when searching anything more than a very small tree. Second one is depth first search. Depth first search going all the way down leaf nodes at the bottom of the tree before trying the next branch over. This strategy requires much less memory than breadth first search, since it only needs to store a single path from the root of the tree down to the leaf node. However, it is potentially incomplete, since it will keep going on down one branch until it finds the dead end, and it is non-optimal. If there is a solution at fourth level in the first, so let the second level in the next one, so let the fourth level will be returned. Specified depth limit. When the search hits a node at that depth, it stops going down that branch and moves over to the next one. This avoids the depth first search of going down one branch indefinitely. However, depth limited search is incomplete if there is a, it is also non-optimal in the same way as depth first search is. Third one, depth limited search. Depth limited search essentially does a depth first search with a cutoff at a specified depth limit to colon. The fourth one, interactive depending search. Interactive, iterative depending does repeated depth limited searches, starting with a limit of 0 and incrementing once each time. As a result, it has the space-saving benefits of depth first search, but it is also complete and optimal, since it will visit all the nodes on the same level first before continuing on to the next level in the next round when the depth is increment. The time complexity of interactive depending search is this node O B. And there's also two last thing in the information about search. It is Javadoc generated documentation for the and directory the search. Gautam, sir, hello sir.
दिव्यांश का okay
Allah.
ठीक है चलिए हाँ ठीक है सर thank you okay
Yeah.
after Divyansh
Okay.
anyone want to present
Gautam, but we have to stop now because I think only 5 minutes left, so we can
yes sir
go
yes sir
for.
sir
So thank you, Gautam. Yes.
sir but how attendance will be managed sir because sir many students are there till many students are there to give the presentation sir.
Okay. Wait, we'll discuss this thing after this session.
Okay sir,
Okay.
okay, sir.
We'll have to plan for it because all needs to participate. So
Yes, sir.
we'll discuss about it. Okay.
Yes.
Thank you,
Thank you,
Gautam,
sir.
and thank you all of you. So we'll meet in the next session. This is after the lunch. Okay. Okay. Meet you in the after lunch.